So now let's look at another data modification that we do quite often. Okay, there are some data analytics methods that require numerical data to be in bins. So you say, like, for example, if you have age going from 20 to 65, then you want to break them up into, say, 20 to 30, 30 to 40, 40 to 50, 50 to 60 and above. Okay, put them into bins. And this is done very often. So here we have a list of ages, right? So now we want to bin them. Okay. Now we can specify the bins you want. Okay, so that will be a list as well. You say you want 18, 25, 35, 60, and 100. Okay. Now if you do a PD, and cut is a pandas method, so that's why we have PD dot cut. Okay. What cut will do is it will take each value and find the corresponding bin and make a code out of it. Okay. So you give the data is ages, and then you have to give bins. Okay. Let's call this cat1. Okay. And then if you print cat1, so what this is going to cat1 is going to give you is it will give you the ages, okay, and it will tell you which bin each value of the age falls into. Okay. Okay, I'm missing a comma here. Okay. So each value, so 20 is which bin 20 falls in, which bin 22 falls in, which bin is 25, which bin is 27, and so on. Okay. And here you need to note that the lower side is non-inclusive. So that's why we have, if you look at each value range, you see the left side is a parenthesis and right side is a square bracket. Square bracket indicates that the value on its side is inclusive, and the parenthesis says that value is non-inclusive. Okay. Now if you want just the codes instead of the values, right, we can say cat1 codes. Okay, so that will give you, instead of the interval, it will give you the code of which interval it is. Okay. So there are 0, 1, 2, and 3. There are 3 intervals. I'm sorry, 4 intervals, 0, 1, 2, 3. And those are each value, which interval it falls into. Okay. You can do cat1 value counts. If you use value counts of the codes, cat1 codes, so here this should be PD value counts. Okay. So it gives you the code and the frequency for that code. Okay. And if you want to look at the instead of codes, you want to have the interval, then we have for that categories So categories will give you the, instead of code, it will give you the interval. So you can do the same thing. PD value counts, if you say categories, then categories, there's something wrong here. Okay. I'll have to look that up. Frequency of bins, so that should go here. Okay. Now we can give labels. Okay. So let's say, well, before that, suppose if you want to reverse the number that's inclusive. So instead of the right side being inclusive, you want the left side to be inclusive. So you can then say right equal to false. Default is right side is inclusive. So what you need to do then is say cat2 is PD cut ages, right? Bins, we have defined the bins, right? And then right equal to false. And then if you do cat2, it will tell you. So like now the third value 25, previously it was between 18 and 25 was the bin into which that went. Now you see that it is, the third is 25 to 35. Okay. Now we can give labels. Okay. So suppose we have G names. Okay. So for each age range, we have a label. Right. Okay. So we have 0, 1, 2, 3. So now if you do cat3 equal to PD cut ages bins. Okay. Now if you say labels equal to G names, right? And then if you say cat3, okay, so I have a typo here. Okay. So now instead of the ranges, we have the labels. So now we can say cat, now if you do PD value counts cat3, then you see that you have a nice frequency distribution with the labels used instead of code or instead of the ranges. Now suppose that instead of giving the value range limits for the bins, okay, you want to bin in a different way. Okay. Instead of giving the ranges, you want to say, okay, I want to take the entire data set and divide it into X number of bins, okay, equal sized bins, right? So we can say, all right, so let's, and the, and it still is PD cut, okay, and then you give the data, say data, and then specify how many, okay, how many bins you want. Okay, of course, let's create a data set and then see how that NP random, so okay. So this code takes the value and then divides them into 4 equal size bins. So let's see. So cat 4 equal to, and then okay, so they are all equal size bins here. Then there is another command or code called qcut. Okay. So there is cut. So far we have been talking about the cut method. So now qcut is the quantile cut where you can specify in terms of number of observations, okay, how many, how do you want to bin them? Okay, so let's say that we have a data, we have created 1,000 numbers, so cat 5, right? So now we say qcut. Okay, we want to take data and then say we want 5 of those. Okay, and then we want to print that and then see. Okay. So now it's divided the data into not equal size, but equal frequency bins. Okay, so they all have 200. So it takes the total observations, divide by the number of quantiles you want. Okay, so you'll use 10 for deciles, 4 for quartiles, okay, and so on. So if you use 10 here instead of 5, then you'll have bins made up in such a way that you get exactly 100 observations in each bin. And we can have custom quantiles by passing a list. So here this will be like, say, cat 6, and we want, well, so bins 2, right? So it will go from 0 to 1, okay, and then you can specify what percentage you want. So this is the number between 0 and 1. So you can 0, then say you want 0.2, 0.5, say 0.9, and then 1. So that means 0 to 20%, 20% to 50%, 50 to 90%, 90 to 100%. So the data will be divided into that many observations. Okay, so now if you use that in your CAT6 equal to PDQ cut, okay, data and bins 2, right? Now if you do PD value counts CAT6, you see that so that would be, I don't know how it got 400. So there is 300. It got switched. Here is where 400 should be. I need to look. Well, yeah, this is not in order. See, this is the first bin, -3 to -0.849. And that has 20%. And after that is this, that has that part, 30%. And then we have that, which has that part. And then finally, the last bin has the 10%.